and screen capture, or yeah, screen sharing, whatever they call that. Okay, so it is um, October 9th. This is our third class for the term, or the beginning of week 3. So let's start out here. Are there any questions? I have not. I'm just now starting to grade the assignment, which was due on Wednesday, and I'll get those graded shortly here. But I got sidetracked with other projects, so um, that's the way that goes. And I've also reorganized or started to reorganize the Desire to Learn site, or the Bright Space Spot site, and it looks a little more like it should look, and it will take more form as we go on. But Module 3 is up and running and ready to use. Okay. One second here. Does anybody see a record button being on? Ah, there we go. We are recording. Okay. First topic. Well, let's go over just what we're going to talk about today. I want to talk about several things today. Here's our introductory slide. And I've got some introductory remarks I want to make, including a little bit of talk about GNU Emacs, about Bourne shell programming, and writing man pages. And then we'll talk a little bit about material in the various chapters. So, next topic. Before we go on to that topic, I want to say a little word about Linux Fest Northwest. There's a lot of Linux activities in the Pacific Northwest, or there used to be pre-pandemic. We have the Portland Linux Users Group, and which is out of Portland. We have a website here, calligator.org, which used to be filled with things, which is basically open source activities in Portland. They don't all have to be open source, but by and large they are. And there used to be 50 or 100 every week in Portland. There's not that many post-pandemic because there's not that many places to meet, but there's still quite a few. And it's a good place to look. One of the groups in Portland, or a couple groups of interest, I will say, is the Portland Linux Unix group, which is a group that I helped found in 1994, 95, something like that. 94, I guess. But I don't come up to Portland very much anymore, so I haven't been to a meeting lately, and they haven't been doing them online. So, but it's a good group. And there's a spring off of that called Personal Telco. They're the people that go around town in Portland mostly installing, helping restaurants and stuff install free internet sites. And Portland was a real leader in making free wireless available to people. Back in the old days, places expected you to pay for wireless. And thank heavens, nationwide, maybe worldwide, that's no longer true. In fact, I'd say that was probably worldwide. Um, but okay. Among the events in the Pacific Northwest is one called Linux Fest Northwest, which is a cool, groovy event. It's in Bellingham, Washington. And unfortunately, when I went to the website, I see it has been kind of canceled this year. It's been canceled like 3 years or so for the pandemic. I used to go to it most every year. Bellingham, if you're not familiar with the state of Washington, is almost to Vancouver, BC. It's very close to the border with Canada. As a result, a lot of people go there from Portland, Seattle, and Vancouver, especially less so Seattle than the other cities, because Seattle's a bit less of has at least historically been a bit less of an open source city. They have some software developer there that makes proprietary things. I forget the name, but in any case, this is a community event. It's free of charge. It's free. It's held at Bellingham Technical College, which is a 2-year college in Bellingham. And it's kind of community oriented. They've got events for kids. They've got a lot of, in normal times, they've got several tracks or sessions running simultaneously. They get in good speakers. Mad Dog Hall has spoken there any number of times. Mad Dog is, I'd say kind of the godfather of Linux. In fact, as I recall, he's the godfather of Linus's children, or at least his eldest daughter. I can't remember other speakers. I've spoken quite a few times, but I'm not I'm not that well known. Anyway, they get a lot of good speakers. It's a great place to go, and it's free of charge, which is wonderful. So it's cool. Okay, going back here. Next topic, I want to say a word or two about the GNU Emacs editor, which I might say a little more on later in the talk. But I just want to say text editors are very important to Unix systems administrators. They're really, a lot of our configuration files are text-based. We do not use anything like the Microsoft registry system. We use a lot of plain old text-based configuration files, and we use a few that are in databases as well. But the result of using so many text-based configuration files, you really need to know a text editor to use to administrate Linux systems. There are a couple that are quite popular. One of them is called GNU, one of them is, GNU Vim. VIM Or most of us old timers just say VI when we really truly mean VIM. VIM is VI improved. And so a lot of, you'll always hear me just say VI, even though I'm using Vim. Another alternative, of course, in the Linux world, if there's one way of doing something, there's got to be 100 ways or 14 ways or something. But an alternative, a very, very popular alternative to VI is called GNU Emacs. And yes, there's 40 editors, there's gedit, there's Kate, there's, I don't know. But the leading stars among editors, among the hardcore Linux people, is VI and GNU Emacs. As a result, GNU Emacs is complicated to use. It's wonderful once you learn it. VI is complicated to use. Not quite as complicated, but it's complicated to use. It's wonderful once you learn it. Emacs is even more wonderful once you learn it. And I encourage people to look at Emacs. It's my favorite editor. And there's kind of wars between the VI people and the Emacs people. I'm clearly one of the Emacs people, but everybody needs to know how to use some VI. The truth is, everybody needs to know how to use some Emacs too, because things like the editing of command lines use Emacs commands, not VI commands. Certain other Linux commands, like more, use VI commands, not Emacs commands. So it works best if you know a little bit of both of them. Okay, the result is well, I don't know what happened. Let me go back here and see if I'll copy that and paste that. Now to copy, in most graphical user interfaces in the Linux world, you can highlight something with your mouse button. You go over to where you want to use it, and if you hit this middle mouse button, it will paste it in for you. And it's pasting it in for me. End of complexity. Okay. Well, in a way, the point is this is like long, but I did a little video a few years ago on GNU Emacs and uses for GNU Emacs. And, if you want to watch it. If you don't, well, don't. That's okay. But I think it helps people get started with using Emacs. Okay. Oops. There. Well, as long as we're talking about Emacs, we should talk about its author. The gentleman that wrote Emacs is Richard Stallman, who goes under the abbreviation of RMS. That's because his email is RMS at the Free Software Foundation.org. Richard is famous for a number of things. And so, The number one person in the Linux world is probably Linus Torvalds. The number two person is probably Richard Stallman. And the number three person is, well, I don't know, maybe Mad Dog Hall, I'm not sure. But Richard Stallman is famous for a number of things. He came up with the idea of the of the Emacs editor. It is a great editor. He also came up with the idea of the GPL, the General Public License. All of this GNU stuff is Richard Stallman's, and it was a brilliant idea, and he pulled it off. He's also known as being very hard to get along with. He's got a toxic personality, but you know, putting that beside the point, and you know, most everybody agrees on that. But putting that beside the point, he has given an enormous amount to our community, and we're quite grateful. So he's got a big Wikipedia page on all the things he's done. That looks like Richard. So, okay. Enough on that. Next topic, Bourne shell scripting. Bourne shell scripting. I'll say one or two words about this. We'll go back to this. You should have learned a little bit of Bourne shell scripting in CS 140U. We will do a little more in this class, and I'm trying to get us started. I'm trying to push it so we get started a little bit earlier. Now, the one thing I want to say is I will always use the word Bourne shell programming or Bourne shell scripting or something like that. Some people call that corn shell scripting, and most of our books will call that bash shell scripting. That's because the Bourne shell and the corn shell and the public domain corn shell and the bash shell and two or three other shells are all essentially the same when it comes to their programming language. The Bourne shell was the original shell used in Linux. And then some people didn't like that, so they invented something called the C shell. The C shell is really, that's the other family of shells. It's really different than the Bourne shell. The Bourne shell was hard to type in all these long commands, so some guy by the name of David Korn added a command line editor for that, and it was called the Korn shell. It was proprietary, so Richard Stallman and his people rewrote it and called it the bash shell, and it was even better than the corn shell. Then David Korn and his son wrote another shell called the public domain corn shell, which was open source. So there's a number of shells floating around. They are, in terms of programming language, they're 99.9% compatible. And I am well aware of the 0.1% incompatibility because I've hit it all over the years. So yeah. Anyway, I will use the term Bourne shell, even if everybody else calls it bash shell. Actually, not everybody does, but the books you read are likely to call it bash shell. And the thing about Bourne shell programming, I don't think it's an awful language. And I don't think you have to be all that good at writing big, sophisticated Bourne shells. If I want to write some big, sophisticated Bourne shell, I'm going to use another language like Perl or Python or Emacs. Only I would do that, but Perl or Python. But it's really important to be really good and comfortable writing short, simple Bourne shells. The big, fancy, elaborate ones, forget. For one thing, I found that when I write a big, fancy, elaborate Bourne shell, I can't maintain it 2 years after I wrote it. So Bourne shell is hard to maintain if it gets elaborate. So, what's really important for us is simple Bourne shells, which are fairly easy to write, and we need to get used to writing them. Next topic is a very short topic on writing GNU, on writing man pages. Okay, remember our man page system. Any command you want, man ls will give you information about the ls command. And it may go on for pages or it may be very short. But, well, I wanted to say any command at all, but that's not quite true because people have gone lazy about writing man pages. But most commands, there will be a man page about them. Man, what's a good, PWD, that's a good command. There is a man page about it. Man, G disk, no, G, yeah, disk. I forget that command. It's a newer command. It's the same as fdisk, except it's a newer version that handles some of the newer disk drive formats better than the old one. And it will tell you all about that guy, all about the command. Man. Okay. And it tells you about the man page, about the man command. And man stands for manual. Okay, now the thing is about this is all of these guys are held in an area called, where are they held now? I forget. That doesn't make sense. Whoop. Well, I'm not going to poke around and find it, but anyway, it's in my video. All of these are held in a certain area. I thought they were there. They're not, but it's stupid. It doesn't matter, but it's frustrating. I can't find them. And they're kept in a they're held in a certain area. They're usually kept in a set of about 8 directories in that area, and called man 1, man 2, man 3, man 4, and so on. And sometimes there'll be ones like man.po for the Polish pages, man.geu for the German pages, although we usually don't install those. But there are foreign language man pages too. And they're kept in those subdirectories. And the subdirectories have various meanings. Man1 is for user commands. Man5, I think, is for description of file system or file special files, the formats of special files, and so on. Nearly everything's in man space 1 or man1 that we want. And they're usually kept in a compressed format, although not always. And then they are written in a weird language called, well, the name varies. It was originally called ROF. Oh no, Runoff, I think. And then it had to be rewritten, and they changed the name to GROF and TROF, and they've gone through a slug of names, but they're kept in this strange format, which is think of it as HTML. It's a markup format, and it's tricky to learn. And I've done a video on how to write man pages, and it is down here. And it's been a little bit of a popular video by my standards, it's got 1,000 viewers or something. But one of the reasons for that is there's very little written on how to write man pages anymore. And it's really important that if you write, if I have a system, a public system, I never allow anybody to put software on that system, or I won't put software on that system unless people write a man page, because software without documentation is worth nothing. So, and what that usually means is the software person comes to me and says, I've never written a man page. What do we do about this? And I usually end up writing their man page. But it's important to have a man page. So I have done this little video on, oops, that's not what I want. It didn't copy. On how to write man pages. Whoop. Oh, that's a stupid advertisement. And a man1. There you go. Anyway, it's just a little video on how to write man pages. Unfortunately, it's a little bit long too, but if you ever need to write a man page, that's where you figure out how to write man pages. Next topic, we'll discuss chapter 5 just a little bit. These are all topics from CIS 140. So we're just going to review this very briefly. Let's go in here. Let's get up our well, let's go over here. I'm going to stick with my system right now. Okay, we've got, we want to discuss file redirection, pipes, various things like that. So standard in, standard out. So let's go over here. Suppose okay, I do an ls command. Ls isn't my favorite command here for this, but that's okay. If I do an ls command, suppose I want to catch that into a file. I could do ls, and now we're going to have to describe why this is funny. But if I do ls and I catch it in a file, which we will call log.txt, then if I copy log.txt, or I send log.txt to the screen, okay, this is the output of the ls command. Now, ls is a weird command because it comes out with colors and in a weird syntax. That's because actually what happens is ls is actually an alias for the ls command. Most commands, I picked a bad command to use. Because ls, when I type it, the screen comes out this way because it's using an alias. Whereas when I redirect it, it doesn't use the alias, and so I get the straight listing. In other words, if I did this, that's a pipe, right? Remember pipes where you send the output from one command and you use it as input to the next command? That looks the same as the file looks. So, so basically you can redirect things like that. And what happens if you use a double one of these? Okay, one greater than sign is file redirection, and it will write over my file. Let's see what we've got here. WC for number of, gives me what, word count of a file? Something like that. WC log.txt tells me that it is I think it's 39 lines, 42 words, and 518 characters. Of course, I could do man of WC to see just exactly what it is. And man of WC, if I actually read this, would tell me if I really wanted this, I could do this here. 39 lines. Okay. Now let's do this like this. Date, what's date do? Oh, that's good. Date goes into, and we will just add that to this file. What was going to happen? Well, let's do WC. I get one line. I wrote over my whole file. Okay, suppose I want that date in the file and the other stuff. Then I could append the other stuff by doing ls pipe to, oh no, not pipe, greater than log.txt. Now let's look at my log.txt. First line is the date I put in. And we can see that what we have is, if we go back and do the WC, instead of 39 lines, I hope I've got 40. 40 lines, that's pretty good. Okay, so that tells us Oh, well, this tells us a little bit about using file redirection and things of that type. Let's do another command here. Let's do oh, and I think I'll just say this. If you use the less than sign, that means input. So if I do this, I use less than log dot text. That's going to use the log.text as input, and I'll get something like that, just like I do here. This is writing. Okay, it's taking the input from the screen and it's repeat and it processes it. So I can type a Control D and that will end my input there. That's an end to file mark. Okay, the normal input, like from the screen, is called standard in, and the normal output is called standard out. So I could do this, WC minus L. This is a line. This is another line. And we'll do a Control D, and we get a 2. I typed in 2 lines, so I get a 2 out. Okay, well, sometimes file redirection can be really useful. Suppose I want to know how many text files there is in an area. Are there any? Here. There's a file that end in a TRG. Or a TGZ. Suppose I want to know how many files there are that end in that guy. I should be able to type find space. Oh, let's see. Is this going to work? Yeah, we'll see what happens here. This print is optional. It's the default nowadays. But if you use some non-Linux Unix systems, you need to put that word print in there because it's not the default in other find commands, like on an IBM AIX Unix machine, as an example. I usually don't put it in though. Name T Z. Okay, what happens there? Ooh, what did that just do? Uh-oh. I don't know what I did wrong, but I'm not going to worry about it. Anyway, what you get here is it prints out all the files by that name. So if I pipe that to WC minus L, that should tell me the number of lines. Guess what? Gives me a 2. So, so that's cool. Now, sometimes I get things that I don't want to get, like this. Sometimes I'll do a find command and I get something like all that garbage. Now, all that garbage is either error messages. Error messages go to a a thing called standard error. And the number that goes with standard error is a 2, as I recall, or it goes to standard output. The error that the unit that goes to standard output is a 1. And just for good measure, the unit that goes with standard input is a 0. But so suppose I'm getting a lot of garbage like this. I think this is standard output. So I can redirect this to, there's a guy over to a file, but there's a special file in the DEV area called null. What null is go out to the ether. I never want to be seen again. And so if I want to just destroy messages, that's what I do. And then they go out to Never Never Land, and I never have to deal with them. Now, they're not piling up over in a file called dev/null because it's a special file. Remember, in Unix or Linux, everything is a file. They grew up in the old IBM mainframes of the IBM in the 1960s, IBM 360s, and well, those were probably 70s. I don't know. IBM 1130s, first computer I programmed on. Everything was a card because people used 80-column punch cards. So they made their whole operating system. They tried to make most things a card. They didn't really succeed, but that was the idea. A few years later, by the late 1960s, the Unix people, Dennis Ritchie, Ken Thompson, people like that, had the idea that there was these hard disk things, so we will make everything a file. And in Unix, everything is a file. If you have a printer, no, it's a file. We call it a special file. And the area/dev is filled with special files. They're not real files, but they are files that are things like printers or teletype machines, if anybody uses a teletype machine, there's a CPU. It's a file in Linux. Anyway, anything's a file. Well, and one of those special files is called null, which is the file that goes nowhere. Actually, here you see standard in, standard out, and standard error are all files. So yeah. Okay. Oops, I want to go here. We have now discussed standard in, standard out, and standard error piping, file redirection. There's more to it in the book. The little bit I did here is really what people use all the time. Some of the options you will see in the book are a little more elaborate, and we use those from time to time, but not every day. Next topic, text editors. Okay, with text editors, as I said earlier, there is VI, there is Emacs, and there are all the others. A lot of people encourage you to use all the others. I don't care, but let me tell you the advantages of VI and Emacs. VI has the advantage that it's almost part of Unix. So if you get onto a Unix machine, if it has any editor, it will have VI. VI is like, it's just there. VI is a weird editor in that, let's do VI. Oh, and you know, this is VIM actually, but we say VI. VI log dot text. And it's a weird editor because it has different modes. So I'd like to put something in here. The cursor doesn't go over there. Don't know what's wrong. I want to enter some text. Well, I can't get over there. That's because I have to go into input mode, and to go into input mode to add at the end of the line, I have to type an A. Now, notice the little cursor came down here that says input mode. I'm in input mode. This is the location of executables. And then I'm in input mode. So let's see. This is something else. Good. Whoop. And now I'm in input mode. So suppose I'd want to save my file. I think I can save that file by hitting capital Z, capital Z. So capital Z, but it gave me a capital Z, a capital Z. I don't want that. I want to save my file. To do that, what I have to do is I have to get out of input mode by hitting the escape button. Once I hit the escape button, I can type capital Z, capital Z. Okay, let's go back into Emacs, or I'm sorry, VI. And suppose I want to find something. I think to find something, I would type a slash, and then I type whatever I want to find, MB. And it goes to the beginning of inbox, which starts with an MV. If I want to get out of Emacs, I could type a colon Q. Or if I've changed my file, that won't get me out. So I need to type colon Q bang. Okay, Unix people often use the word bang for exclamation mark. It's common to use the word bang instead of exclamation mark. I probably use exclamation mark, but certainly I know what bang means. Okay, the textbook describes the use of VI. Everybody needs to know some VI because VI is on every Unix machine in the world. Even I, as an Emacs person, knows some VI. I know at least enough VI to be able to install Emacs and edit my .emacs file. Now, the truth is, I know more VI than that, but I am not a VI expert. I know enough that I can edit a file in VI, but I'm not really a VI expert. VI experts, there are a lot of sophisticated things about VI, and there are a lot of professional programmers use VI, and they use it really well. One of the things about VI is it's on all Unix machines. Another thing about VI, it will edit the longest file you can imagine. It, I like Emacs. It will edit long files. 1,000,000 lines, no problem. 10 million, maybe you break it into two, then it's no problem. A lot of these editors will not edit 1,000,000 or 2,000,000 or a 5,000,000 line file. Gedit, Kate, all of those guys, they won't edit big files. Now, most files aren't big, so it doesn't matter. But I happen to deal in some huge files. Things like AutoCAD DXF files, which are AutoCAD drawings turned into ASCII codes that you can edit to repair broken drawings and things like that. And when you're dealing with data files, they can get enormous, just huge. And you need an editor that can handle those. VI is the best editor at doing that. Emacs is a great editor at doing that. Most other editors don't stack up to either of those when it comes to that type of application. Okay. Now, the thing about VI, though, is it's got these various modes. Why has it got these various modes? VI was written way, way, way back before we had soft terminals, when people were maybe using paper or using terminals that were with cathode ray tubes that they weren't perfectly flexible. So they kind of gave you a screen-oriented mode, but they didn't make everything screen-oriented. So it dates back to really the old days. Emacs was one of the early truly screen-oriented editors, but it's got arcane commands too. So, and it's got 1,000,000 commands. So it's a learning process. Okay. Next topic, very, very brief next topic on writing Bourne shells. Suppose we want to write a Bourne shell. Okay. The first thing I do in writing a Bourne shell, we're going to write a Bourne shell and we're going to call it my first Bourne shell. Now, I always end a Bourne shell in a .sh. Or the bash people, I think they sometimes end them in .bsh. I can't remember. I always end them in .sh. Oh, there was one other thing I wanted to mention. I just typed in VI instead of typing in VIM. What is that all about? Why? That looks the same. Okay, let's go over to /bin maybe, I don't know. Oh, look at there. There's two files in this directory, VI and VIM. Now, /bin is where they keep all of your, well, no. /bin is where they keep a lot of your commands and executables. I was going to say all, but no. They also keep some under /USR/bin. They keep them under /SBin. They keep them under /USR/SBin. They keep, I don't know where they keep them. But a lot of your commands are kept under /bin. And the reason I can't tell you exactly where all the commands are kept is they do vary a little bit based on what distribution you're using or what Unix you're using. But on almost all systems, there's a lot of commands kept under /bin. Okay, top level directory. We go to slash. There is a top level directory called bin. That guy will have, and as it happens, it's got two files in here, slash for VI and for Vim. Let's type this. Okay, notice what these are. These are links. Well, I don't know what in the world is this thing. This dash greater than. Well, that dash greater than, as I recall from when I took, well, I never took it. When I taught CIS 140U, that is a symbolic link, right? So VI here points to this file here, which is Vim. And Vim points to the same file, which is, and that is probably the code to Vim. Let's type down here. Well, actually, we could do this, right? File, VI. It says those are symbolic links. Surprise. /USR/bin /VIM or VI. Uh-oh. Oh, there's too many things in that. Oh man, that's a pointer to something else. Well, those are both pointers to something else. This shouldn't be where I keep executables, but let's look at it. And that is a link to yet something else. Okay, we're in links to, the hell of links. You can get into this. There's a link to this, a link to that. Man, we're going around in circles in links. But someplace in there, and the point is, notice they're all pointing to the same place. Now, let's take a look at this last one here. I didn't expect this, but, that's a file with some length. I think there's a command called file or something like that that is supposed to try and tell me what a file is or what type of file this is. It says it is an ELF 64-bit. Well, an ELF file means it is an executable file. That is C code after it's been compiled and linked with various libraries, and that's a C program, or could be Fortran. I don't know, but I do know it's a C program because Unix is primarily written in C. And VI and VIM are written in C. Okay. So that deals with that. So let's take about a 5-minute intermission here and come back in 5 minutes. And then we'll continue with things after 5 minutes. My coffee's cold. Starting to rain, which is good because we really need rain. But I got a lot of walnuts sitting on the ground that I need to pick up yet. And tomatoes and green beans and things like that. It's um, anybody have any questions? Is anybody having any difficulties with the textbook? Everybody's very quiet. Oh, also, I think I want to make a change to my office hours. Instead of doing Thursday evening, I'm just going to hang out here after class for an hour or so, and so people can ask me questions, and or we can discuss issues. So I'm going to move the one set from Thursday evening to Monday morning, and of course it always by appointment, so it works out fine. Okay, should we start again here? Next topic, we have discussed chapter 5. Let's go in and discuss chapter 6 a little bit. And let's take a quick look at what chapter 7 is. Okay, let's discuss chapter 6. Chapter 6 is on managing local users and groups. And one of the big jobs that Linux systems administrators have is managing their users, because you in Linux or in Windows, I don't care. The way you keep security is by having users on a system and knowing so users only have access to certain files, or they only have write rights to certain files. You don't want Jane being able to write over Sam's files, or maybe you don't even want Jane to be able to see Sam's files. That, that depends on the nature of your organization. So user management is very important, and it's a little, and both user management and file protection is very different in Unix than it is in Windows. Okay, the first thing about Unix is what? There is a user that some people call super user, whoever super user is, or I will call him root. There is a user called root. Root controls everything. Root has access to everything. Root is really the Unix god. Root really, and that's why if you have a system, you have to be very, very, very cautious about who you give the root password to. You don't want the root password spread out. If somebody gets access to the root password for your system, they've got total control. The other thing is, I don't know why this is, but on every Unix system I've ever worked on, root has the username root. I don't see, there's no real reason for that. You could use a different name than root, but every distribution I know of, every Unix I know of, every FreeBSD I know of, they all use the username root. As I say, I've always been tempted to change that on a system, but I never have. And apparently no one else has either. And then there is a command called sudo. And what the sudo command does is the sudo command gives normal users access to be root, to do root commands, Okay. Well, let's go out here. Let's go over to our systems here. I've got a couple systems here. One of them's running Red Hat 9. One of them is running Almar Linux. Let's take the Almar one down. And I left this up because it's just using up resources that I don't want to use. But when I take a system down, there's a number of ways of taking a system down. But you don't want to just turn it off. Just like any other computer, if it's a virtual computer, you want to shut it down so it shuts down in an orderly fashion. The one command for that is shut down space -H means halt, -R would mean reboot. Do that in 0 seconds, or no, do that. I don't know what the zero's for. That's where my fingers go. It's been there for decades. I'd have to do a man page on that. And then the word now. That will shut down the system. The other command I could use is I could type in the command halt, and that would probably halt my system. I think that works in Unix, or I'm sorry, in Linux. I think in some Unixes I have to type halt sys. Another command I could type would be init space 0, and that would set the run level to 0, which stops the system. Anyway, this is the command I've been using for the last 30 years. It works good. I'll use it. Now, of course, I have to be root to use that command. So let's play with this command a little bit before we take it down. Okay, I don't know who I am. There's a command called ID that will tell me who I am, to give me information about me. It says that I am a user dmandel, that I'm in a group dmandel, and that my UID is something, and so is my GID. Well, anyway, I don't know what those are until later in the lecture. So, and so I'm an ordinary user. If I would type in shutdown -H 0 now, it wouldn't work. It did work. That's a whole new topic. Darn it. I was hoping that wouldn't work. It did work. Anyway, I'm supposed to have root privileges to take a system down. And the reason I don't need that is apparently the shutdown command has a sticky bit set, which is later. So I had root access for a little bit. Well, anyway, so be that. Well, who am I on this system? I'm a user called Red Hat with a UID of 1000, and cool. Oh, and this is a system that actually I haven't done a thing with this system. This is a system we set up in the last class. So it's pretty bare bones. What users does it have? Well, one way of figuring out what users are on a system is just to ask what users are in the /home directory, because usually when we have a user, we add them to /home. So their home directory would be under /home, and Red Hat is under /home. So we probably only have 1 or 2 users. Well, there's the root user. Now the root user usually has its home in a different location. Its home is usually under /root or something like that. And permission denied. I'm not allowed to look there. Okay, so So what I'm saying is, often when I want to know something about users on a system, I just do an ls of /home, but that's not 100% accurate, because if somebody didn't add a user to /home, I could have a user on a system I don't know about when I just do that. Instead, what I really should do if I want to know about the users on the system is there's a directory called /etc. Anybody know what /etc is used for? Well, /etc is where most of the Unix system's configuration information is kept. So it will have files like these here, some of which I'm not even sure what's in them, many of which I am sure what's in them. But they've got to do with systems configuration. One of those files is our good friend password file. Password file has a list of all the users on the system. Down here, you see Red Hat is on the system. And some of these are fictitious users in the sense that they're just users that run various services. Like that VBox add is just something to do with VirtualBox. It's needed to keep VirtualBox running. The same with TCP dump. Or SSHD. These are basically, phantoms, daemon processes that run in the background. And there's a user at the top called root. Root has the UID of 0 and is in a group of 0 and controls everything. So that will tell us about the users. Now, notice something bad here in that I got into that as a normal user. I don't have root rights there. So boy, I probably shouldn't store the passwords in there. And it used to be in the old days that X was where the passwords were stored. They were kept in an encrypted format in the location where the X is. And it meant that anybody could read the encrypted passwords really easily, figure out how to decrypt them, and you had access to everything, including the root password. Not so good. So they moved the root passwords, or they moved the passwords to a file called shadow. Guess what? I don't have permission to read shadow. The only guy that's got permission to read shadow is, whoa. Whoop. Is the only person with the permission to read shadow is root. So yeah. And as long as we're talking about files in this area, there is one more file over here called groups. Group. And that file has information about what group people have access to. Now, everybody has a default group, and then they can also do a new group command or something to change the group they're in. Usually that command is very rare you ever have to use that. But these groups are important because the software itself will change groups temporarily for you anytime you need access to another group to do something, if you have the permission to be part of that group. So those are the three files that are really important dealing with users. The other file being, and the fourth file being your home directory. And the files in your home directory, well, the things in your home directory. Okay. So suppose we want to add a user to a group, and I'm going to have to look up how to do this, but if we want to add a user to a group, we might do it using the command user add. Oh, I don't know. When you don't know, there's a man page. And there is a man page here for this guy. And this will tell you anything you want to know about user add. Yeah. Why isn't that command called add user? Well, historically, the reason for that is in Linux 0.9 or something. In the earliest Linuxes I used, that command was called add user, but that command had problems. They didn't want to eliminate that command entirely when they made new revisions, so they added a command called user add that did it right. And then over the years, they've dropped the add user command, I think. Nope, it's still there. Well, anyway, we want user add. And then we're going to need to use a lot of flags. And I'm just going to look up what I normally use. Oops. Here's one here. It says that I should use -m, -c with my name. So I'll go back here. I'll use -m. I don't know what -m does. So I'd better figure out what -m does. Let's start a new terminal. User add. Now, this is the more command. I typed man, but man uses the more command. If you want to find things using more, you use VI commands. So I would use a slash to find -m. -m. Oops. Well, that's not working that well. -m says create user. That's the same as create the home directory. So we want -m. Then we want -c. David Mandel. Now this isn't going to work perfectly, but then we want the group and the user, the UID. So we will want the group and the UID and I think the home directory comes next. Oops. Home directory comes next. Home directory is, oh boy. /D. Back here. Home directory. We will make the home directory in /home/D Mandel, and then the username /D Mandel. Okay, now this isn't quite going to work because there is no group by this name. And so the first thing I have to do is make a group by that name with add group. So let's go back here. We'll save this command with an echo or something. We'll do user group. Oh, wait, none of that works. I'm not allowed to add users. A normal user can't add a user. I have to be root to add a user. I can become root in a couple ways. One way I could become root is I could do sudo and then do the command. Any command in a world, or I could do all the root commands with using the sudo. It will come back the first time and ask me for my password. It will either ask me for my password or it will ask me for the root password, depending on how sudo has been configured. On a Red Hat system, by default, it will ask you for your password. They really should be configured to ask you for your password because you should be able to do this without knowing the root password. Well, hell, it doesn't matter because I could change the root password. So I guess it doesn't really matter. Most systems are configured so when you use the sudo command, you have to use your password. A few are configured so you have to use the root password. Anyway, the other way to become root is to do an su -u. SU is usually called super user, but there's no super user to SU. SU means substitute user, and it allows me to become any user I want. So if there was a user dmandel on the system, I could do that command and become dmandel. Of course, I'd have to know dmandel's password unless I was root, but usually the way it's used is it's just su /dash, and that is for becoming root. So it will ask me for the root password. I think I know the root password, and then I will become root. Do you want to use su or do you want to use sudo? I think on big systems with lots of administrators, making everybody use sudo is better because that will give you log files on who became sudo if something screws up. On most systems, a lot of us work as root quite a bit, but only work as root when you're doing root things. Don't work as root when you're not doing root things because root has total control of the system. So if somebody's going to put bad software onto your system to violate your system, some system cracker, they're going to, if you run that software as root, you're going to end up giving them all the marbles in the machine. If you end up running it as a user, they're only going to get your stuff. So, you know, don't, I mean, this is a cardinal sin to do non-root things as root. It's the way viruses get passed around. It's really it's a huge security cardinal rule. Okay, I am root. So now I should be able to use user group add. And I've got to look up the syntax for that too. Now I'm doing a cardinal sin here, and little cardinal sins, we all do them. That's not bad. I am using the man command as root. I could, and I probably should be using the man command over here where I am not root, but I'll use it as root. I'm saying this because that means if somebody cracked into my system, some which way managed to put some bad software into the man command, a command that's totally irrelevant, they could actually get valuable things because I executed that as root. So, you know, be cautious. And that will give me information about adding things as root. We'll want group add. I think I've got it documented here though. Oh, there goes. That's all I've got to do. Minus G. Is that right? Let me go back and check one more time. That looks right. Let's execute that guy. Okay, after executing that, if I should look under the file /etc/groups, I don't know if that's going to be in there or not, but there it is, right there, last line. Okay. Going back here, then I should be able to add the command I don't have that in my command line stack. So I need to type that in again. User add let's see if I can get this from someplace. If I take this out here, it's not in my clipboard. Okay, Control C. Things are not going smooth here. Copy. Let's go over here. There, paste. Okay. There's my command, just the way I want it. So let's execute this command. That's all there is to it. Now, having executed that command, we should have a new user. I don't know. Let's see what we've got here. That looks like there's a new user /D Mandel. Let's see if he is in this guy, the password file. Sure enough, he is. Okay, with that, let me log out. Whoops. Now I've got a real problem. Which dmandel is this? Well, let's log on. Oh, you know, I didn't set the password. Okay, which dmandel am I? Well, I happen to be the red hat one, which is lucky because I did not set a password for the new dmandel. Let me set a password for that. Root can set the password for any user. Password dmandel. Change password for dmandel. Let's open a new terminal here. New window. Actually, we're going to expand this to full screen for the moment. Gives me more real estate. Now, I should be able to substitute user for dmandel. Who am I? I am now dmandel. So that password actually probably works. Everything's good. And I have added a user. Now, one of the questions I would have if I was you, where in the world did I come up with the UID of 44345? That makes no sense at all. And if I had used the defaults, if I had not put in the, I wonder if I've still got this, user add. Yeah, if I had not put in, oh boy. I did this wrong, but that's okay. If I had not put in this 44345, I would probably be 1001 or something like that, because the first user added got the GID of 1000. The next user, if I don't put in this -u space thing, the next user will be 1002, the next one 1003. But I just out of my hat, I pulled out four, 44345. Why did I do that? And I should also have made that group 44345, but I did not, but that's okay. I'll talk about that in a moment. Going back to our Unix class, Unix has all these funny things about access rights for files, right? How does it keep track of access rights for files? In the file system, it doesn't keep track of your name. This is where Unix is different than Windows. Windows actually keeps track of your name or something like that. But Linux or Unix, the same. Linux does not keep track of your name. It keeps track of your UID, because the UID takes 2 bytes of information. UIDs can go between 0 and 2 to the 16th minus 1. To the 15th, well, anyway, 64,000. And to the 15th minus 1. Because they only store they use 2 bytes of information to store the UID numbers. The way Unix does this, they store everything very compactly, and they're able to check access rights incredibly quickly, very, very fast. But that means that UID is very, very seriously important. Because suppose somebody else has the UID of 44345. Then somebody they'd be on their system. They might format and write something to a thumb drive, like this. They format the thumb drive using a Unix file format. They write their information onto this thumb drive using the CP command, and they are user 44345. Okay, some which way I find this thumb drive. I put it into my system. Guess what? Because I am now user 44345 on my system, I have access to all their files. So if I have a system with a lot of computers, I really want to keep everybody having the same UID numbers and the same group numbers and all of that stuff. I really want to keep that very coordinated across my system. Not only does that happen with a thumb drive, but suppose let's see, Windows, you share a disk across, you share the disk from the file server. In Unix, you mount it with, you mount an NFS disk from a file server. You got to have those UIDs coordinated and the group numbers coordinated. If they aren't, you're going to get total chaos in terms of who owns what files. So 44345 is my UID, which I've been using for 25 years, maybe. Actually, closer to, since about 1990. So, and I use that on Unix systems. I use that on Linux systems. Now, there's a problem. I only use that on the systems I control. If somebody else is in charge of the systems, oh, then pain intrudes, and you got to worry about security. And there's ways of taking care of all of it, but pain intrudes. So, if at all possible, keep your user IDs the same every place. So, now the other thing I talked about was the group numbers. And I don't know what to use for a group number. There are two philosophies on this. One philosophy says, we live in a nice, friendly world. We're just going to use a few group numbers. We'll put almost everybody into a group called users, which is the group 100 that we can see up here. And that on most systems, the group 100 is the group users. And that's cool. And then we won't let that group write a lot of data, but we will let it read a lot of data. So people can read pretty much across files. People can read other people's files pretty easily. That works really great if you're in a scientific environment where people are kind to one another and people want to share information. It doesn't work worth a darn if you're in a law enforcement agency or a intelligence agency. You got to do something different. Those people say every time I add a group, every time I add a new user, I not only add a new UID for the user, I add a new UID or a new group as well. So in that case, I should be in group 44345 and in user 44345. Distributions vary on how they do this. I live in a SUS world and other worlds that basically throw everybody into the group users by default. We can do it the other way, but the default is to throw everybody into the group users. And that used to be extremely common. As Linux is used more and more for business applications, it's become less common. And most distributions, I think, including Ubuntu, Debian, and Red Hat-like distributions, by default, make a new group every time they make a new user. So on this system, I should have built a group for 44345 called dmandel and put dmandel into that group. I didn't, I forgot. And I'm kind of running short on time. Okay. Well, we've talked about the bare minimum of what we need to talk about for adding groups, using groups. There's also a command called delete user or del user or something like that. I don't use that command. Never delete a user because you don't want to reuse that UID. And besides, when users quit and go elsewhere, they tend to come back and into another position after they're gone. You still want to access their files, which are bound to that UID number. So my philosophy is never ever delete a user. Just I won't say never ever, but almost never ever delete a user just disable the account, change its password so nobody knows what it is, or actually there's other ways of disabling. There's ways in the textbook of disabling user accounts, but disable the user, don't delete the user. At least that's, yeah. Voice of experience, I don't delete users. Okay, we did not talk much about file permissions. They are really bound up in being users, and we covered that pretty thoroughly in, I hope, in CS 140U. We may talk about it a little bit next time if we need to. If we don't, we won't. And it will come up as the course progresses. Now, the last thing I did want to mention before leaving is this program here. And I left these names open because they're not students. And they're people I know that I don't think would care. I just look here, Moshe's, I guess, being bombed right now in Israel, but I wish people wouldn't fight wars. It's too bad. In any case, this is an example of what I say is a little systems administration program. Up here, as I recall from my Unix class, I always put in # and then the directory of the shell that I'm using. And I always call this the Bourne shell. The truth is, it's the bash shell. If I traced my links back like I did with that other command, you'd find that this is a link to the bash shell. Then you put in some documentation. Apparently, I wrote this in 2007, but which says, keep your programs around because you'll want to use these as templates for other programs. This little command here, ignore. You don't need this, but I put it in. Basically, it's my, I don't know, it's code here that I wrote that says, don't run this program unless you happen to be logged in as root. What happens if you're not logged in as root? Well, all these things blow up and give you error messages. They don't do any harm. So, this code is all optional. Copy it if you like it. It actually took me a little bit of time to come up with that thing, but copy it if you like it. If you don't like it, forget it. You don't need it. And then this was, this is a command to add a group. This is a command to add the user, so on and so forth. And what you do is you just put in the commands to add all your users. Often you can do that by pulling this information out of, say, a spreadsheet or a table that somebody gave you and manipulating that in a good text editor like Emacs or VI, where you can write macros. You can manipulate that thing so that you can write these very quickly, very easily, really quick and easily, and you're not writing a lot of code. You're not typing in every line. And that's why it is so much faster doing this than typing in every line and executing. Oh, it'd be a pain to execute these by hand, just this many. But suppose I have a class, like a class and I have to add 20 students, and maybe I've got 3 classes and I've got to add 20 students for each one of the classes. You know, it gets to be a lot of work. And then the way I usually give passwords is by hand. The truth is, there's ways to code it, to write code to give the password. I might cover that another time because it can be tricky, actually. I've had trouble writing code to change somebody's password. It's easy to do one by one, but it's a little tricky to write code to change their password. I don't know why. After I discovered the system, it seems pretty easy, but it took me forever to figure out how to do it. So, okay. I guess that's everything. And this is a barn I used to own, and I ended up having to tear it down. It was just too rotten when I bought the property, and I did everything on earth to try and save that barn because it's a beautiful building. And I ended up having to take it down, so we'll use that as the photo for the end. Okay, I'm going to turn off recording, and then I'll stay around for a while, at least an hour. So I'll be here.